today's class, let us learn relationship between zeros and coefficients of a polynomial. In my last class, I have already explained how the zeros of a linear polynomial p of x equal to ax plus b is related to its coefficient. Say for a polynomial, linear polynomial ax plus b, then the zeros of p of x is nothing but minus b by a. What is b? B is nothing but the constant term. So it's a constant term divided by coefficient of x. Coefficient of x, right? So this is for the linear polynomial. Now let us learn the relation between the zeros and coefficient of a quadratic polynomial. Suppose I have a polynomial of this kind, ax square plus bx plus c. Then how the relation is between zeros and its coefficients? We'll explain with example. Say suppose I have a polynomial p of x equal to say 6x square minus 7x minus 3. Okay, this is my polynomial. Now you have already studied the factorization of the middle term. Okay, you studied in your earlier classes. So the product must be minus 18 and sum must be minus 7. Which two numbers I have to take? Product must be minus 18 and sum should be minus 7. 6 into 3 I can take, but 6 plus 3 will be 7, so I cannot take that. Then next option for product 18, it is 9 and 2. Minus 9 and 2 if I take, their product is 18, and if I add minus 9 with 2, and then I am getting minus 7. Okay, so I'll factorize this term, middle term. I'll rewrite this as minus 9x plus 2x minus 3. Okay, so I want to find the zeros first, then I have to check how it is related with the coefficients of a polynomial. Okay, so to get the zeros I need to factorize this, so that this will be, now in these two terms I can take 3x out, so the remaining is 2x minus 3, and here I'll just take 1 outside so that it remains same. Now this 2x minus 3 is common, so I can write 2x minus 3 into 3x plus 1. Okay, to get the zeros I have to equate this p of x to 0. So p of x equal to 0, 2x minus 3 into 3x plus 1 is equated to 0. Product of two terms equal to 0. When it is possible, either this is equal to 0 or this is equal to 0. So 2x minus 3 equal to 0 or 3x plus 1 equal to 0. This implies 2x equal to 3 and x equal to 3 by 2. Here 3x equal to minus 1 and x equal to minus 1 by 3. So you got two zeros, one is 3 by 2 and another one is minus 1 by 3. Zeros are minus 1 by 3 and 3 by 2, right? Now I will take these two zeros, I'll just denote it as alpha and this as beta. Okay, Greek terms I'm using. I'm taking this as alpha and this as beta. 0, 1, first 0 is minus 1 by 3 and second 0 is 3 by 2. Now we'll take sum of this, sum of zeros. sum of its zeros. Okay, that is alpha plus beta. If you want, I'll just write it in bracket, alpha plus beta. What is this? This is minus 1 by 3 plus 3 by 2. It is 6 here, minus 2 plus 9, so that it is 7. Now this 7 by 6, you just observe, this is same as writing minus of minus 7 divided by 6, right? What is minus 7? In my polynomial, minus 7 is nothing but coefficient of x, right? So I'll just rewrite this is nothing but minus coefficient of x. And what is 6 in my polynomial? 6 is the coefficient of x square. So I'll just rewrite it as coefficient of x square. So you can write sum of its zeros is nothing but minus of coefficient of x divided by coefficient of x square. This is the first relation between the zeros and the coefficients. Now let me take product of the zeros, product of its zeros. Product of its zeros, that is alpha into beta. Alpha into beta. Alpha is minus 1 by 3 into 3 by 2, right? 3 will get cancelled. I am getting minus 1 by 2. Now what is minus 1 by 2? You can check, see, in my polynomial I have numbers 6 as the coefficient of x square, and minus 7 as coefficient of x, and minus 3 as a constant term, right? Now I am getting minus 1 by 2. See, if I take constant term, that is minus 3, and the coefficient of x square, that is minus 3 by 2, which is nothing but minus 1 by 2. Now this is simplified to this, and which is same as this. So I can write product of zeros is nothing but constant term divided by coefficient of x square. Did you get? So for a quadratic polynomial, in general, if I say if alpha and beta are the zeros of a quadratic polynomial, just write in general, if alpha and beta are zeros of the quadratic polynomial, p of x equal to ax square plus bx plus c, where a is not equal to 0, then alpha plus beta, which is nothing but sum of its zeros, is equal to minus b by a, and product of its zeros, that is alpha into beta, is nothing but c by a. Okay, this is very much important. For a quadratic polynomial, sum of zeros is equal to minus b by a, where b is nothing but coefficient of x divided by coefficient of x square, and product of zeros is nothing but constant term divided by coefficient of x square. I will explain with one more example. Suppose I have a polynomial p of x equal to x square minus 6x plus 8. How to factorize this? Product should be 8 and sum should be minus 6. 4 into 2, yeah. So x square minus 4x minus 2x plus 8. So I'll rearrange this, minus 2x minus 4x plus 8, so that it's quite easy. X I'm taking out, so that x minus 2 over here, and here I'm taking 4 outside, minus 4 outside, so that x minus 2 remains inside. X minus 2 is common in both, so I'll take it out. The remaining is x minus 4. So from this p of, to get the zeros, I have to equate p of x equal to 0. So that x minus 2 into x minus 4 is 0. Product of two terms is 0. This is possible only any one term is 0, right? In fact, both the terms can be 0, but mainly when you take a product of two terms equal to 0, we take either this is equal to 0 or this is equal to 0. So x minus 2 equal to 0 or x minus 4 equal to 0. X equal to 2, x equal to 4. So zeros are alpha equal to 2 and beta equal to 4. Okay, now I have to check sum of the zeros. See, the question will be like find the zeros of a polynomial. They'll give you the zeros of the polynomial and they'll ask verify the relation between the zeros and the coefficients. The question will be like this, and they'll give you the polynomial. You need to find the zeros first and you have to verify the relation between zeros and coefficients. For that you have to check alpha plus beta. This alpha plus beta must be equal to minus of coefficient of x divided by coefficient of x square. Okay, that you have to check. So alpha plus beta here, 2 plus 4 equal to 6. Okay, now you just take minus of coefficient of x divided by coefficient of x square. Take this, minus coefficient of x is minus 6. So minus 6 divided by coefficient of x square is 1. So which is nothing but 6. They are equal, right? I'm sorry. Yeah. Coefficient of x is minus 6. So minus of minus 6 divided by coefficient of x square. Coefficient of x square is 1. So plus 6 by 1, which is 6, which is same as this. So alpha plus beta is equal to minus of coefficient of x divided by coefficient of x square. One verification is done. Next I have to check with alpha into beta. 2 into 4, it is 8. Now this should be equal to constant term divided by coefficient of x square, right? Coefficient of x square. Constant term here in this case is 8 by coefficient of x square is 1, so it is 8 only. They are equal, right? They are equal, so the second condition is also verified. So the question will be find the zeros of a polynomial. They'll give you the polynomial, okay, and verify the relation between the zeros and coefficient. So you need to find the values of alpha and beta, check whether alpha plus beta is equal to this and alpha into beta is equal to this. Okay, this is the verification part. Now these are all for the quadratic equation. Now what happens, see, if they give you the zeros, then can you get back to the polynomial? That is the question. I'll just tell you how to do that. Suppose it is given that alpha, beta are the zeros. Alpha and beta are the zeros of a polynomial, say p of x equal to ax square plus bx plus c with a not equal to 0. Okay. Now alpha and beta are the zeros, and you know when they are zeros, you know alpha plus beta equal to minus b by a and alpha into beta equal to c by a. This you know, right? Now what I do is, when alpha and beta are the zeros of a polynomial, then from this I can write x minus alpha and x minus beta are the factors of this polynomial. Do you agree? Factors of the polynomial p of x. See, you just see here, when I got this, x equal to 2, x equal to 4, alpha equal to 2, beta equal to 4, then what does it mean? You go back, x minus 2 equal to 0. What is x minus 2? It is a factor in the polynomial p of x, right? So if alpha and beta are given to you, then they are zeros of a polynomial, then you can directly say that x minus alpha and x minus beta are the factors of the polynomial, quadratic polynomial. So I can write this ax square plus bx plus c equal to, I don't know whether it is directly implies this, or I have to multiply something, either a constant 1, 2, like that, I don't know. So what I say is, this is a factor of this, and some k times, k is some constant, k times x minus alpha into x minus beta gives me this polynomial. This is my assumption, and I don't know what is k. Remember one thing, this k must be a constant. Okay. See what happens here when you take the last problem here. See here you got this x minus 2 into x minus 4 equal to 0. It might be, if there is some number over here, then the value of alpha and beta won't change. If I multiply whole equation by 4, this whole thing is multiplied by 4, this whole is multiplied by 4, this whole thing is multiplied by 4, this whole is multiplied by 4. So 4 is over here. Now then I cannot write 4 equal to 0. 4 cannot be equal to 0, right? So x minus 2 equal to 0 or x minus 4 equal to 0. And so this is a dummy part. It won't matter much, okay, when you are finding the zeros of a polynomial. So same thing I'm saying, either it is directly equal to this, or some constant terms must be included or must be multiplied to get this. Okay, so I'm just writing, if these are the factors, it may be multiplied with the constant, need not be necessary, it may be equal to 1, 2, I don't know. Okay, I'm just making a guess. Okay, now I'll multiply this k into, k is any constant, I'll just write any constant. Now x minus alpha into x minus beta, x into x is x square, x into minus beta is minus beta x, minus alpha into x, minus alpha into minus beta plus alpha beta. Okay, now I'll rewrite this, k x square minus k beta x minus k alpha x plus k alpha beta. Okay, just rewrite once again, kx square, combine the term which has x as a common term. Okay, here this minus k beta x minus k alpha x, they have x in common. Okay, so I'll just write them as k into alpha plus beta into x plus k alpha beta. Now you compare this equation with the left hand side equation. K equal to A from these two, right? Now B equal to minus K into alpha beta. So B equal to minus K into alpha plus beta, and you compare with the constant term. This says C equal to K alpha beta, right? So now K equal to A, I'll just substitute over here B minus A into alpha plus beta, and again K equal to A, I'll substitute over here A alpha beta. You rewrite this alpha plus beta equal to minus B by A, and alpha beta equal to C by A, right? So if you are given with alpha beta zeros of the polynomial, then you can get the polynomial back just by using these relations, right? So sum of the zeros equal to minus B by A and product of zeros equal to C by A. These are Greek letters. In fact, alpha and beta are the Greek letters we are using, and one more is there, that is gamma. It is written something like this, gamma. Okay, sorry, slight change. What I do is I'll give you sum and product of the zeros. Instead of directly giving alpha and beta, I'm giving you alpha plus beta and alpha into beta, and have to calculate the have to get the quadratic polynomial. Okay, so how to do that? What you know, sum of the zeros, that is alpha plus beta, is nothing but minus B by A. Here they are giving you alpha plus beta as minus 1 by 4, sum and product of zeros. So alpha plus beta is minus 1 by 4, which is equal to minus B by A. So minus A, what you can say, these two fractions are equal, right? So minus sign, no problem. From this you can write B equal to 1 and A equal to 4. Similarly, product of zeros alpha beta is 1 by 4, right? Alpha beta is nothing but C by A. C by A equal to 1 by 4. So from this you are getting again A equal to 4 and C equal to 1. Two fractions are equal, so you can directly write this. Okay, so you got A, B and C values. So how is any quadratic polynomial? How are we writing? P of x equal to ax square plus bx plus c, right? So A value is 4x square plus B value is 1, so I'll directly write x plus c. This is my polynomial, right? See, sometimes what happens is you can even check whether you are correct or not. Okay, you just find the zeros of this polynomial and add them and check whether you are getting this, and you multiply the zeros and check whether you are getting 1 by 4 or not. Okay, now let us take cubic polynomial. Okay, P of x equal to ax cube plus bx square plus cx plus d, where a is not equal to 0. Now in this, how the zeros of cubic polynomial is related with the coefficients of a polynomial. Before taking the general term, I'll take up a cubic polynomial and we'll check with their coefficients. Okay, since it's a cubic polynomial, you are going to get 3 zeros, right? At most 3 zeros. So let me take zeros as alpha, beta and gamma. Okay, we'll take up one example. say P of x equal to, so cubic polynomial, it is written in this form, suppose, make it quite easy, x minus 1, x minus 2 into x minus 4. Okay, this is the polynomial. You can guess the zeros of this polynomial. In fact, no need to factorize and all, they have already factorized it. So can you tell me what are zeros of this? Yeah, alpha is 1, beta is 2 and gamma is 4. Okay, from this directly you can make it out. Still I have to simplify this. In fact, I want to have the values of a, b, c and d. Okay, it's not given directly, right? They have already factorized, so I have to go back and have to get this. Okay, so let us do that. I'll multiply these two first. X minus 1 into x minus 2. So x into x is x square, x into minus 2 is minus 2x, minus 1 into x, minus 1 into minus 2 is plus 2 into x minus 4. This is so that x square minus 3x plus 2 into x minus 4. Now I'll multiply this, x cube minus 3x square plus 2x minus 4x square plus 12x minus 8. So that x cube, then minus 3x square minus 4x square. So it's minus 7x square, 2x plus 12x, so 14x, and the constant term is minus 8. So P of x equal to 0, I can directly write, to get the zeros, I have to equate P of x equal to 0. That means x minus 1 into x minus 2 into x minus 4 equal to 0, which implies alpha equal to 1, beta equal to 2 and gamma equal to 4. Okay. Now we'll check with the sum of zeros and product of zeros, how they are related with the coefficients of x cube, x square, x and the constant term. Okay, so let me take sum of zeros, alpha plus beta plus gamma. Alpha is 1, beta is 2 and gamma is 4. This is 7. Here in my case, in my polynomial, okay, I'm getting 7 over here. Just keep it as it is. I'll just rewrite this 7 as minus of minus 7 by 1, right? Minus of minus 7 is 7, divided by 1 it won't matter. So what is this? What is minus 7? Minus 7 is coefficient of x square and 1 is coefficient of x cube. So I can write minus of coefficient of x square divided by coefficient of x cube, right? This is sum of the zeros. Now I'll take product of zeros, alpha into beta into gamma. That is 1 into 2 into 4, which is 8. Again this 8 I can write, I have minus 8 over here, right? So 8 I can write minus of minus 8 divided by 1. Where is minus 8? Minus 8 is a constant term in my polynomial. So I can directly write minus of constant term divided by coefficient of x cube, right? This is sum of zeros and product of zeros in case of a cubic polynomial. See, I explained so far with the example. Now in general, how they are related, we directly write. Okay, so if my cubic polynomial is of the form ax cube plus bx square plus cx plus d with a not equal to 0, then alpha, beta, gamma are its zeros. Then we write three relations here. In quadratic polynomial, we just took sum of zeros and product of zeros. Here I'll add up one more. Okay, I'll explain that. Sum of zeros, alpha plus beta plus gamma. This we have observed in the previous problem. It is equal to minus of coefficient of x square divided by coefficient of x cube, which is nothing but coefficient of x square is b and coefficient of x cube is a. So, which is equal to minus b by a. Next, we'll take a product of zeros, that is alpha into beta into gamma. This we got in previous problem, minus of constant term divided by coefficient of x cube. So, which is nothing but constant term is d divided by minus d by a. Next is sum of products of zeros taken two at a time, means I am taking two zeros at a time. I am not taking all the zeros, I am just taking two zeros at a time and taking a product, and then I'll add up. That is nothing but alpha into beta plus beta into gamma plus gamma into alpha. Sum of products of zeros taken two at a time, right, which is nothing but c by a. Okay, this is very important. You must remember this in case of cubic polynomial. So, we'll explain this with one more problem, because in the last problem we have not done this. Okay. So, they are giving you the polynomial, say p of x equal to, you need to find p of x, and they are giving you this sum of the zeros alpha plus beta plus gamma as 12, and product of zeros, this is given for you, alpha plus beta plus gamma is 12, alpha into beta into gamma is 60, and the sum of product of its zeros taken two at a time, in the sense I am taking two zeros, I am multiplying and then I am adding. Product of its zeros taken two at a time, okay, is 47. In the sense they are giving you alpha into beta, beta into gamma and gamma into alpha, which is equal to 47. So, you have to solve this. Okay. Now, we know alpha plus beta plus gamma is equal to minus b by a, right. Here they are giving you it is 12 equal to minus b by a. Then alpha beta gamma product alpha beta gamma equal to minus d by a. How much it is? It is 60. In this case it is equal to minus d by a. Now then alpha plus alpha beta plus beta gamma plus gamma alpha equal to c by a. which is nothing but 47 equal to C by A. I'm sorry. So now you check everywhere this 12 can be written as 12 by 1 and this 60 can be written as 60 by 1. This 47 can be written as 47 by 1. So you just say these two fractions are equal. So from this you can say A equal to 1 and B equal to minus 12. And from this you can say A equal to 1 and D equal to minus 60. And from this you can say again this value should not change. If it is varying, then you have to check, okay. You might have gone somewhere wrong or like that, okay. Here in this case it is quite easy, so I can directly write A value I am getting 1 and the C value is 47. So how is the general form of P of x? A cubic polynomial. It is ax cube plus bx square plus cx plus d, right. A is 1, so x cube plus b is minus 12, b is minus 12, so I can write minus 12x square plus cx, c is 47, so 47x plus d is minus 60. So this is my cubic polynomial. Here they have given you sum, product and product of two terms at a time. So these things they have given you and you are calculating the polynomial. In few cases what they do is just like the quadratic polynomial, they are giving you zeros, 3 zeros they are giving you, and they'll ask you verify these zeros of a cubic polynomial will satisfy with the P of x, okay, and you check the relation between its coefficients and zeros, okay. I'll list out few problems, you try by yourself. So these are few problems based on zeros of a quadratic polynomial, okay. And for the cubic polynomial, I forgot to mention one thing. In this problem, so they have given you these values, no? You can directly write this, but this is not the safest way, okay. In fact, what happens is when we write this P of x, no, in general if we are writing, then as I did in the quadratic polynomial, same way we are multiplying it by k, okay. Here I am not getting any k values over here, I just explained you how to do it, okay. So some k value, there may be this equation might be multiplied with any number like in 2 by 2 or something like that. So of course the value of k does not alter the values of zeros, okay. But sometimes what happens is they'll give you something like this, say P of 0 is something, some say 24 and something like that they'll give you, then you can find the value of k. Along with this, okay, along with this they can give you something like this, so that you can substitute over here and get the value of k, okay. I just explained you how to do this. Sometimes they'll give you the zeros of a cubic polynomial and they'll ask you whether it is the zeros of a cubic polynomial, you just check, okay. In that case you have to take this alpha plus beta plus gamma equal to minus b by a, these three relations you take out and check whether they are satisfying. If they satisfy, then you can say that they are the zeros of. In my next class, we'll discuss how to divide two polynomials. In fact, division algorithm for polynomials. Thank you.